Hi folks, Dr. Ditchek. It is Monday evening, July 20th, continuing with our COVID education forum and other healthcare matters. Today the story is about T cells in the news and in the research. And, for folks who've been part of this forum for months now, you know that we've spoken extensively on the possibilities related to T cells and B cell and memory immunity. Whereas I think the lay folks have been very focused on the IgG antibody immunity, which I think everybody can agree upon now that this is not the story of long-term immunity for COVID. I think that's clear from the research, but let's talk about why. I'm going to post on this site very shortly a piece that was in the lay literature from the BBC, the British Broadcasting Corporation, that actually put up a very comprehensive article reviewing some recent findings from the British literature on T-cell immunity. And what the article questions is, do some people have a hidden immunity to COVID-19 that we didn't know about before? And the latest research actually suggests that antibodies against COVID-19 may have existed in certain individuals from many years ago, T-cell immunity, that they were unaware of from exposure to previous viruses that were similar to COVID-19, but that left them with a long-term T-cell immune response. So whereas we now believe that the IgG antibodies in many people, especially those that had mild to moderate disease, dissipate or decay over a 3-month period, or somewhere about there, in many people, we don't believe that the T-cell immunity does the same necessarily. So this review spoke specifically to the point of whether T-cells are playing a role in an immunity that might have existed well before the pandemic for a certain number within our population. So where would that long-term immunity come from for COVID-19? And again, the answer might lie, it appears, in the T cells. Now, certain research groups have looked at blood samples that were collected many years ago, some of them going back 25, 30 years, blood samples that were frozen for other research purposes. And they went back and started looking at the T cells that were present in those blood samples, or individuals who donated blood samples, going back 25 to 30 years. And what they found was very interesting. They found specific T cells that were tailored to detect the surface protein of COVID-19. Now, these long-term T cells are actually, another name for them is T killer cells. These T killer cells have surface receptors which bind to the surface receptors of the COVID virus, and they destroy these very dangerous invaders. So where would that have come from? So some of the early studies suggest that individuals who had other viruses many years ago developed these T cells, these T killer cells. It's possible that those viruses were simply old beta or beta coronaviruses, the kind that caused the common cold, or maybe other viruses that mimicked COVID-19 but were clearly different. But yet these individuals developed T cell responses enough to defend against COVID-19. Some studies suggest that there might be twice the number of individuals previously thought who were actually naturally immune to COVID-19 just from having had certain old previous viral infections. And if you remember, we spoke on this forum about this about 2-3 weeks ago, in that we thought that communities where individuals had many children, specifically certain Orthodox communities where there were high birth rates, that because those children had many colds and other infections, that maybe certain people who were around those children, like their parents, had some beneficial immunity just from being around such frequent infections. We spoke about it vis-a-vis pediatricians as well. Pediatricians are folks who are around a lot of infections on a regular basis. Is it possible that they also have some natural or T-cell immunity? We don't know the answer to it, but this study suggests that individuals in the community might actually have these T killer cells that are present from previous infections. Some of them may go back many, many years. Some studies that were reviewed suggest that 40 to 60% of unexposed individuals had T cells which were dwindling and appear to be a result of age. So here's where the rub lies in terms of T cell immunity. Uh, we know that this disease was far more deadly to senior citizens, people older than 65. We also know that individuals older than that age lose their T cell, not only the function of their T cells, but the production of their T cells. So that's the problem partially with vaccine development for senior citizens, that we have to make sure that we make a vaccine that works for them as well, since young people have much more robust T cell responses. So where do these T cells come from? They come from the human thymus gland, the gland that sits in the front of the chest. It's actually developed as early as the fetal age, before babies are born. The function of the thymus gland peaks somewhere during the fetal and neonatal period. That means the amount of T cells that are being put out by that gland are very robust in newborns. By the age of puberty, the size of the thymus gland peaks, and starting at about in the late 20s or 30s, the gland starts to shrink both in size and function. So the gland by the age of, let's say 50 or 60, is about 10% of the size that it is of a newborn, of a child in puberty. Now, this is very important because we know that children do better overall with COVID. We haven't answered the mystery as to why they do better with COVID, but it could lie behind the fact that children specifically have very robust T cell responses. They have very robust T cell production, and they have very active thymus glands. And as you know, we've reported on this forum, as in many other forums, that I saw babies during the peak of the crisis in April and in March who were born to COVID positive mothers, who were COVID positive babies, and I didn't see a single baby who got sick during the neonatal period after birth. Not a single fever, not a single cough, not a single pneumonia. So it is very possible that those T cells were already activated as early as the fetal or newborn period and might have protected those children. I think it all points to the fact that T cells are the answer to the immunity puzzle in all likelihood, not IgG antibodies. So we're looking at the wrong target, unfortunately. Not we, scientists are looking at T cell antibodies, but I think we as communities are inappropriately looking for immunity from IgG, simply because it's so easy and cheap to measure. T cell immunity is not easy or cheap to measure. It's done in highly specialized laboratories. The good news relating to T cells, actually, and this is why I raised it, Oxford University today published in The Lancet their early trials with the Astra Zeneca vaccine. This is one of the vaccines that's actually using another virus to help create a more robust response. I believe it's adenovirus in addition to the coronavirus DNA. And what they discovered in their phase 1 and 2 combined trials, which I think was on about 1,000 individuals or a few more than that, is that during the first 14 days of the after administration of the vaccine, there was a very robust T cell response. Remember, those are the killer cells that can neutralize COVID virus. And if you stretch that observation period to 28 days to almost a full month, there were a significant number of additional neutralizing antibodies present. Now, this vaccine, like the others, is recommending 2 doses because the response was much better, apparently, in the small number of people who got a second dose. And right now, they've gone on to phase 3 trials. They're starting shortly in the US, the UK, Brazil, and South Africa. Now, the reason the trials have to take place phase 3 now or in the near future is that the FDA and the European FDA have put a very high bar on approval for this vaccine, basically saying that once a person gets the vaccine, in order to approve it after the safety has been confirmed, is that 50% of people who are exposed to the virus thereafter must have a protective immune response. In other words, won't get sick from COVID-19. So the bar has been set very high from an efficacy standpoint by the FDA. The bar is being set even higher from a safety standpoint because they're asking that the phase 3, those are the efficacy trials that are being done now with the Moderna vaccine and soon starting with the AstraZeneca Oxford vaccine, that those be going on for another 4 to 5 months to make sure that we're creating a safe vaccine. And I am confident that they will create at least 2 to 3 safe vaccines over the next few months. The question is, when will it arrive? I don't think we're going to see this vaccine until the late December, early January, but there are plans to produce billions of doses of these successful vaccines if they happen. So I think the message tonight is Immunity, it appears to be most likely related to T cell immunity, not simple IgG immunity. Most likely, we don't have a confirmation of that, but certainly the research is pointing to robust T cell responses as defensive mechanism for COVID. The other good news is that the Oxford University Astra Zeneca vaccine studies are very promising, much like the Moderna one was. We still don't know what the extended phase 3 studies will look like. That's yet to be determined. But all good news, I think, on that front. So we'll sign off for tonight. I think we had a lot of useful information tonight, and let's keep positive and hope that we get a great vaccine soon to get life back to normal. Take care.